and hopefully you guys can hear me over all of the chiming in. It looks like we have tremendous interest in our online demo. Uh, I need to find somebody who needs to be muted here. If you all could mute your lines, that would help us a lot. And we will open it up for questions towards the end. Thank you for dialing in today. My name is Sean Nunley. I'm a CISSP and sales engineer for Fusion IO. And with me, I have Mark Johnson, who is our Oracle subject matter expert. And today we're going to be giving you a very quick demo of Fusion IO and applying Fusion IO technology to Oracle databases. In this demo, all we're doing is putting data as close to the CPUs as possible. This is much like a memory tier within the server built on Flash. I'm going to give you a really quick introduction to Fusion IO, and then we're going to go right into the demo, have it over very quickly, and then we're going to let you ask our expert anything you like about this demo or your own Oracle infrastructure. If you could mute your phones during the demonstration, it would help everybody out. And if you have questions, just type them in the chat box, and we'll try to get those questions answered first towards the end of the demo. So what is this? ioDrive is really a memory platform on the PCI bus inside of a computer. It uses flash like SSDs, but if you learn nothing else today, know this, that we are nothing like SSDs. SSDs, in fact, are flash memory put behind a hard drive interface, and what we actually are is memory sitting on the PCI bus right next to the CPU. So this reduces latency, eliminates I/O bottlenecks, and delivers the performance of thousands of drives. I'm going to pause for just 1 second here and try to mute some of this noise we're hearing. Once again, if you have the chance,
Hey, Sean, I think you just muted all of us.
Sorry, I don't know who did that, but thanks for telling me. ioDrive is basically a PCIe card sits inside the server delivering this kind of low latency. Today we're going to look at applying this technology to Oracle Database I/O. The reason that we are so fast and completely different than an SSD is explained pretty well in this slide here. In this slide, what we see is what a SSD, or really any hard drive, has to communicate in order to get data into RAM. As you can see, there are a lot of steps. The application asking for the data going through several transformations and repackaging, and then finally ending up in RAM. The cut-through architecture of the ioDrive is really what gives us the biggest advantage. In the ioDrive, we literally already have a map of the data. Sorry about that. Any chance that you guys could mute?
Are you able to hear?
Sorry, I'm trying to track down the noisy users here. So really the advantage here is this cut-through architecture, and you're going to see this advantage any place that you apply ioDrive technology. Today we're going to be showing Oracle Database. Now, there's a lot of different ways to use Fusion IO. Historically, people have used it, as you see there on the left, as performance storage inside the server. But you can also take this memory platform and apply it towards caching of data on your existing storage. This speeds up I/O tremendously inside VMs as well as for bare metal servers. And there's a third way to deploy us, which is actually as a storage target on a LAN, where you take our standard cards, put them in a standard server, and wrap our Ion software around it, and it becomes a very fast LUN on the storage network. Now, accelerating Oracle can come in a lot of different flavors. We're going to focus on one very simple one today, which is using the local ioDrives as storage. But you can do other things, like you can move just the temp files, redo files, strategic lifting, put that on the ioDrive to make it faster. You can use the Fusion drives as Oracle's smart flash cache. You could put your Oracle data out on an Ion, for example, or you can use the Ion as a preferred read mirror. With that, what I'm going to do is pass the ball over to Mark Johnson so he can quickly get into the demo. Mark is a certified Oracle professional, 22 years in the business, and has actually written a book on Oracle, which you can see there. And with that, I will pass it to Mark and spend my efforts trying to mute all of the all of the other noise that's going on here. So 1 second while I make that transfer. Mark, you could start talking now.
All right. Sorry. I had muted myself earlier just so I didn't create any extra background noise, and I forgot to unmute myself as I started giving my presentation. So I'll just start over here on my my speech. What I'm going to do is I'm going to open up a GUI window, remote desktop into a Linux server that I have here in my lab. It's just a commodity rack mount server. It's only 2U rack mount, and it's got OEL 6.2 with Oracle 11.203 Enterprise Edition. But I'm not going to use any of the fancy features of Enterprise Edition for this demo. On that server, I created 2 Oracle databases. One is called FIO, and the other one's called HDD, which is supported by all hard disk drives. The databases were created from the same script.
Hey,
so,
Mark,
yes.
Are you sharing your screen yet? There you
I
go.
am. Starting right now.
Thank you.
All right, so at this point, everybody should be seeing my Linux desktop. It's got a red background with 3 PuTTY windows open, or terminal windows, I should say. And in the upper left window, I'll try and make that a little bigger. These are all the storage devices. You'll see that there's the boot drives plus a bunch of hard disks. And then there's some devices down at the bottom of that screen named FIO A1, B1, C1, D1. The ones just represent partitions on the devices. And what I have in this server are 2 of the Fusion IO cards that Sean mentioned earlier. They're simply flash memory chips on a standard-looking PCI card. They insert directly into the server. Some of the cards that Fusion IO sells, they're referred to as duos because they actually have 2 banks of memory on one physical PCIe card. So devices FIO A1, B1 are actually one card, and FIO C1, D1 is a second card server. And if I look at the setup of ASM in this window, make it a little bigger. Again, you'll see I have two disk groups. The names are on the right, FIO and HDD. Back on the left, ASM says these are mounted with normal redundancy. Since I have multiple devices with normal redundancy, this is equivalent to RAID 10. Right. The amount of space I have is roughly equivalent between the two disk groups. It's about 1.2 terabytes in each of the two disk groups. Again, the FIO database is going to be dedicated to the FIO database. The HDD disk group is going to be dedicated to the HDD database. And that is it for the setup. Now let's take a look and see how this actually works. What I'm going to use is a tool called Swing Bench. And first, let me get my hard disk drive database set up here. Okay, got my SID and everything set. And I'm going to launch a tool called Swing Bench. You can download this for free and run it against your own databases. Okay. This is what the Swing Bench control panel looks like. I've got a name and a password. I just have to make sure I'm pointing to the right database and test that. Great, it works. You have the option to collect AWR statistics and take snapshots. I'm not going to do that for this demo. You can control the number of users. You can control how much time in between each user logging on and so forth. Let's just go ahead and kick this off. I'll explain more while it's running. Again, I'm not collecting statistics, so I'll ignore that warning that popped up. But it says all users logged on, and over here on the right above the red graph that's building, you'll see I've got 32 users logged on. I could do a lot more users. The server I'm using is not particularly big and beefy. It's got 12 processor cores in it. But just to start a test, I thought I'd go with 32 users, and we can crank it up later if we want. Okay. The charts are building steadily, and they'll continue to do that for a while. The red chart at the top shows us how many transactions are completing per minute, and a little over 1,000 and climbing. The gold chart below that simply divides it by 60 and gives you transactions per second. The middle of the screen shows response time in milliseconds. I don't want you to get overly concerned with these high numbers like 1,000 milliseconds, 5,000 milliseconds, because that's not the disk I/O response time. That is the end-to-end application response time that includes the application layer, the networking, the hard drives, everything. And then way down at the bottom, we see the disk I/O throughput measured in kilobytes. So that's about 3 megabytes per second going through. Now, this has been running for just a couple minutes. You see the graph is starting to taper off. And we're actually getting around the peak throughput that we're going to see from this test. It's about 1,700 to 1,800 transactions per minute. You will notice over time, to be honest, this goes down, back up, because it's running a variety of tasks. You'll see at the top of the screen, it's registering customers, browsing products, ordering products. It's running through a mixed workload. Okay, so here we see it dipping, but if we wait, it'll go back up again. Right now, it's doing lesser number of longer running transactions. When it's done with those, it'll go back to running a whole bunch of really short transactions again. But we've got a pretty good feel for it here. We've peaked out at just under 1,800 transactions a minute, and if we look at the bottom again, about 3,200K per second, which is 3 megabytes a second of throughput. All right, so this is the database, remember, running on traditional hard disk spindles. Not a lot of spindles. Certainly we could attach this to several $1 million worth of sand and get these numbers higher. But let's just say, well, if you had a terabyte of disk and you replaced it with a terabyte of Fusion IO, what's going to be the difference here? Test my connection in Swing Bench. Again, I'm not going to bother collecting statistics or making AWR reports in this test run. I'll use the same 32 user sessions that I had last time. We'll kick this off. Now remember, the number I'm trying to beat is 1,800 transactions per minute. And before I had the chance to even open my mouth, we're 30,000, 40,000, 60,000, 70,000, and it just keeps climbing. If you look at the bottom part of this picture on disk IO, remember we're trying to beat 3,000 KB per second, and right now we're at about 600,000 KB per second. 600 megabytes a second. So we've gone from 3 megabytes to 600 megabytes per second. That's a 200x improvement. The transactions per minute still climbing. We wanted to get at least 2,000 to beat the hard drive configuration. We're more than 100x above that at this point. Now, another thing, while this is still running, I want to let it run for a few minutes so it has a chance to do some ups and downs and stabilize. But remember earlier I said, don't worry too much about response time, because it's the end-to-end, not just the storage system. And when I was telling you that, the hard drive response time graph was at about 5,000 milliseconds. Now it's down to 27. So from 5,000 down to 27. And the average has dropped from over 1,300 to 6. Now that is just the end-to-end. It's not the storage layer isolated. If I were to look at something like Oracle Enterprise Manager, I can click here on the I/O tab. We'll let the chart come in. Look at the first chart here on the I/O page. This is latency for single block I/O measured in milliseconds. I'm hovering right on 0. I just barely get above 0. And normally in an AWR report with Fusion IO, you'll see 0.1 millisecond wait times for all data files. Finely tuned SAN, $500,000 to $2 million investment. You're probably looking at anywhere from 3 to 8 millisecond response times. Here, I just popped 2 cards in a server, and I have somewhere less than 1 millisecond. This particular test is not overly stressing the system. You'll see I'm only doing about 50 to 60,000 IOPS right now. And about, according to this chart here, I'm only doing about 425 megabytes per second. So I'm not really stressing the system. I could certainly get a lot more out of this system, increasing the user count. But again, look at these transactions per minute. I wanted to beat 2,000. I'm at 234,000. I'm going to go ahead and stop this. It would stop on its own eventually. I'll click the stop button. Now, there are a lot of different ways that the Fusion I/O technology can be used or leveraged to accelerate Oracle. We have in-server storage solutions. We also have, as Sean described earlier, an external storage solution where the same cards can be put in a commodity rack mount server, and then with our software called Ion, we can present it back to your Oracle database servers, both standalone and Oracle rack, to provide a centralized shared storage solution. We also have caching solutions. We work with the Oracle Flash Cache, and we have our own technology called Direct Cache for virtualized environments. ioTurbine works with VMware solutions and so on. All right, so I'm going to get out of this window.
Okay.
Close this window up here.
Alrighty.
Sean, let's go ahead and bring the
Okay. All right. Bye.
we'll bring the main presentation page back online.
Okay, hang on one sec.
And while you're doing that, just a little bit more about the throughput numbers. The 2,000 transactions a minute that we were getting off these hard drives, that would be for a server, whether it's a floor server or a rack mount server with internal drives. Certainly, you could plug in a very expensive SAN solution and get that number up from 2,000 into the 100 to 140,000 IOP range. Your transactions per minute would similarly go up. The same could be said for simply putting more cards in the box. I had 2 Fusion I/O cards in this box. There are servers that will hold anywhere 8, 10, all the way up to 14 of these cards inside a single server. And IOPS can easily go into the hundreds of thousands, 400,000 and up range. We've had a couple demos, I think even at Oracle Open World, where we beat the million IOP. Let's see, Sean, do we have the presentation up? Yes.
Yes. So right here, what I did is I, in the background, graphed those results that you got, and as you can see, the numbers here are pretty staggering. We got about 141 times the number of transactions on average, and latency dropped from 1,800 milliseconds down to 6 milliseconds. So pretty staggering achievement. I apologize for the beeps. I think the next time we do this live demo, we'll turn off all the beeps and auto-mute everybody. But so there you go, a live demonstration of what we can do on a server right in front of you. And here's some results that our actual customers have experienced in the field. And Mark, you want to talk a little bit about these Oracle results in the field?
Absolutely. So I'll start by pointing to the link that's on the bottom of this slide. So you can go to the FusionIO.com website and go to the case-studies page, and you'll find a seemingly endless supply of case studies for Oracle, SQL Server, MySQL, Microsoft Exchange, VMware, and Virtual Desktop, and it just keeps going and going. What we've done here is we've taken just 5 random case studies that were specific to Oracle. For example, a Libris online bookseller, 6x faster searches. So that's kind of important. If you're an online retailer, and maybe you're helping people book hotel rooms or flight reservations, well, when I say search for a flight tomorrow going from Washington to Los Angeles, it better come back pretty fast. If I have to keep waiting and waiting for something to happen, I'm going to go to a competing website and rerun that search. And so it's extremely important for online retailers to get the data back as quickly as possible and present that next web page to the customer. Is 6x normal? When I go into a pre-sales engagement, I like to play it down and say, let's shoot for 3x, maybe even 5x. Well, you can see here we're getting numbers between 4x and 40x. So it's kind of a wide range. I don't want to tell people up front you're going to get exactly this or you're going to get exactly that. It depends on your application. It depends on the profile in which you're using the data. Okay, but I would say that 6x is pretty easily achievable number. Again, these case studies and more are available on fusionio.com/case studies. It's all open. You do not need to register or anything like that to see the case studies. You just go there and search for it.
Hey, now, Mark, that was a fantastic short demo, and I really appreciate you doing this for us. What I want to do now is open it up to questions in the field. I don't have, I've got most everybody muted, so if people can type their questions into the chat box, we can try to answer your questions that way first, and if it's not too crazy, I can start unmuting people as they raise their hands. So I think you have a way to raise your hands there in WebEx, and we'll give that a shot. But one of the first questions we had right here was about the hard drive configuration, Mark. Can you talk again about the hard drives we were testing against?
Sure. So they are typical 2.5-inch hard drives that would come with any commodity server that you would buy. We show a bunch of our partners here on this page. The server I used in today's demo is a Supermicro. I have the same hard drives in all my HP servers. I have 10K RPM and 15K RPM. You can only fit so many hard drives in a server, and your performance is going to be constrained by that until you invest in the larger and more expensive SAN or NAS infrastructure. All right. In today's demo, we were simply looking at in-server storage solutions and comparing putting as many hard drives as I could fit in the Supermicro server versus just putting in 2 Fusion IO cards. There were 4 PCI slots in the box. I could have put in 4 cards, but remember at the beginning of the demo I showed the 2 ASM disk groups, and I showed the capacity for both was 1.2 terabytes. I didn't want to put in any more Fusion IO cards because then I would have really skewed the numbers there.
That's great. That's a great answer, Mark. So the next question we have is from Federico, and he's asking, how do we address centralized access to a DB? For example, if you had a 8-node rack cluster, could you still use Fusion IO as the data source?
Yes, but you're going to do it a little bit differently than I did in today's demo. As you know, Oracle Rack requires shared central storage, and the PCI cards that I mentioned, they were put directly into the demo server. So Oracle Rack really can't do anything with those cards. There is an option in Oracle called the Oracle Database Smart Flash Cache, and inside each of your rack nodes, you could put a Fusion IO card locally in the database server, and configure the flash cache to use that card. But as far as storing the actual database files, you can't put them on those cards. We have to abstract it out of the server to a central location, and that's what we call ION, I-O-N. So if you go to our website, fusionio.com/products, you'll see we have the cards that go in the server, and we also have ION for external storage, and that works with Oracle RAC, but it also works with standalone Oracle, Data Guard, and so on and so forth.
Great answer. So ION is our shared target solution, so that can be used with anything that requires a SAN target to work against. We have another question from Tony, which is, are all the objects on today's demo on Fusion IO, and what would you normally want to put on Fusion IO? Want to take that one, Mark?
Oh, I'm sorry. Can you repeat that question real quick?
So are all the objects on today's demo, all the data on Fusion IO for that test? And then secondary question is, what would you typically want to move to Fusion IO?
Okay. If we had a mix of things and we were trying to prioritize, then we'd probably start with like an Oracle AWR report and look at the pain points for your particular database. Maybe in the top 5 weight events, we'll see single block IO, or as Oracle refers to, DB file sequential read. A little, confusing name. It's sequential because it's going into sequential buffers in memory, but it's more or less random reads off the disk. But in any event, so at that point, we see we've got a storage IO issue. Maybe we go down to the IO stats with an AWR report or stats pack, and you'll see the table space statistics, the data file statistics, and so we're looking at, look at these table spaces with an average response time of 5 or 8 milliseconds. Let's try moving those table spaces onto the Fusion IO. If you're a read-heavy environment, you're doing a lot of big queries and reports or analytics, then obviously the temp table space becomes a pain point for you, and you want to move the temp table space on the Fusion IO. If you're heavy into writes, you do a lot of insert, update, delete, then it's the undo table space. Pretty much for everybody, it's also the online redo logs, but it's going to depend. We have to look at it on a case-by-case basis. I had a customer, I didn't know he was a customer, came up to me at Oracle Open World and said, I wanted to let you know we're using your product for Oracle Golden Gate acceleration. The only thing that we've moved onto Fusion IO is the Golden Gate trail file. It's kind of like a transaction log, right? But that was the only thing they moved to Fusion IO, and after doing so, the end-to-end Oracle performance increased 100%. So, we have a rule of thumb that says move the redo logs and these other files to Fusion IO, but it just depends on how you're going to use the Oracle software.
Great answer. So another question from Joshua, which I think is always an interesting question, is what is the cost difference to run Fusion IO versus a traditional setup? And let me take that one for just a minute. Essentially, when you look at the cost difference between one thing versus another, the real correct way to look at that is what is the overall cost of that, right? So if today by traditional you mean setting up your database on a big metal SAN storage system, then you have to consider the cost of that SAN storage, all the spindles that are in it, the power to run it, the floor space to house it, the people that are skilled in running it as well. So there's usually a pretty tremendous cost to support these high-end databases. With Fusion IO, we're actually removing quite a bit of that legacy architecture. So with the card right in the server, there are no switches and cables and other things to support. So if you look at the cost cost of Fusion IO, even against just SSDs, it's still a good deal because, believe it or not, the Fusion IO card itself is more reliable than just the RAID controller that connects those other SSDs. So there's a lot of creative ways to look at the cost. What we can tell you is this is really a good play in terms of keeping your costs down. It keeps your infrastructure smaller and more simple, easy to operate, and most importantly, it allows you to get 5x, even more times the transactions from that same Oracle server. So in the end, you're paying a lot less money for Oracle licenses. So that would be my quick answer to that question, which is if you look at the whole ROI on this, Fusion IO ends up being much, much cheaper. The next question we have is if using it as tier 0 in front of a SAN environment, what are the best practices around protecting, replacing the data in Fusion? So this question is pretty interesting. So what we're saying is if you've got a tier 0, if you're actually using the card in a server as a cache in front of other storage, are you risking any data? The answer there is no. Because when we behave as a cache, that tier 0, we're actually just caching reads and delivering blocks that you've already read or seen. Writes go all the way out to the primary storage and have all the redundancy that you would expect from that particular SAN. With that, I think we're out of questions. And if anybody else has one more question, go ahead and type it in the chat box. I'm not going to open up the audio because it's just crazy. There's hundreds of people in this conference, and I really appreciate you guys taking the time to see Fusion IO and see our demo. We're going to be giving this demo on a regular basis. I'll be sending out more invites to these as we go along, and you can look forward to seeing more Fusion IO live demos in the future. I did have one last question here that I want to answer. What is the max capacity of a Fusion IO? We have drives that range from 365 gigabytes up to 10 terabytes on a single card. So the capacity is really only a function of how many slots there are in a server or how many ions you want to hook up. So we can literally host many terabyte databases. So if you have any more questions, be sure to call our number that you see on your screen there and get in contact with your Fusion IO people, and we'll be happy to show you how Fusion IO can work in your environment. And thanks again for attending our conference. With that, thank you, Mark.
All right. Thanks, everybody.